We are going to discuss about hydration of cement. On adding water to the cement, the silicates and aluminates present in the cement start a chemical reaction and form a spongy mass known as gel. During this process, a large quantity of heat is liberated. The quantity of heat liberated depends upon the amount of different constituents in the cement. In other words, hydration of cement can be defined as a reaction taking place in water and cement paste by virtue of which Portland cement becomes a bonding agent. There are two ways in which compounds present in the cement may react with water. In the first case, on addition of water, the cement compounds dissolve to produce a supersaturated solution from which different hydrated products are precipitated. This is true reaction of hydration. In the second case, what happens? In the second type of reaction, the water is hydrolyzed. Actually, the term hydration is applied to both true hydration and hydrolysis. The products of hydration of cement chemically are the same as the products of hydration of individual compounds under similar conditions. The fact was first stated by Le Chatelier. Main hydrates can be classified as calcium silicate hydrates and tricalcium aluminate hydrates. The two main calcium silicates are the main cementous compounds in the cement. The physical behavior of cement during hydration is similar to that of those compounds alone. Is that the dicalcium silicate and tricalcium silicate are the main constituents which are present. Maybe if we talk about the percentage composition or chemical composition, the dicalcium silicate and tricalcium silicate are the main two compounds present in cement. Now, calcium silicate hydrates. In modern cements, total amount of calcium silicate hydrate varies from 70 to 80%. The rates of hydration of tricalcium silicate and dicalcium silicate. Now we have two types of hydrates, like the calcium silicate hydrates and tricalcium aluminate hydrates. When we talk about the calcium silicate hydrates, there are two main calcium silicate hydrates which are formed by hydration of tricalcium silicate and dicalcium silicate. When water is added in a limited quantity, as in the case of cement paste or cement concrete, tricalcium silicate undergoes hydrolysis first. That is, among the dicalcium silicate is that C2S and tricalcium silicate C3S. C3S is that the tricalcium silicate is the first to undergo reaction or first to undergo hydrolysis, producing calcium silicate of lower basicity. Ultimately, C3S2H3 or CSH gel is produced. C3S2H3 or CSH gel is produced, and lime is that calcium hydroxide is released. These hydrates, the dicalcium silicate makes the reaction. Now ultimately both tricalcium silicate and dicalcium silicate produce CSH gel and the final product of hydration and releasing a fixed amount of quantity of calcium hydroxide. The amount of quantity of calcium hydroxide released in case of tricalcium silicate is double than that released with dicalcium silicate. On the weight basis, the amount of calcium hydroxide is not a desirable product in concrete mass, as it is soluble in water and may get leached out, making the concrete porous. Thus, in hydraulic structures, cement with higher percentage of dicalcium silicate should be used, because tricalcium silicate produces more amount of calcium hydroxide. It has been observed that the hydration of tricalcium silicate does not take place at a constant rate. The initial rapid release of calcium hydroxide into a solution leaves an outlayer of 10⁻⁻⁶ cm thick of calcium silicate hydrate. After this, for some time, very little reaction takes place. The period of little reaction is called as dormant period. Is that among the different products, tricalcium silicate is much more reactive as compared to that of dicalcium silicate and hydrates more easily. Then we have tricalcium aluminum ferrate. The amount of tricalcium aluminate in most cements is comparatively small, but its behavior is very important. The reaction of pure tricalcium aluminate with water is very violent and leads to immediate stiffening of paste. The immediate stiffening of paste is called as flash set. This immediate stiffening of the cement paste is called a flash set. That means tricalcium aluminate is mainly responsible for the flash set of cement. To prevent flash set, 2 to 3% by weight of clinker. Gypsum is that calcium sulfate with twice H2O is that CaSO4 2 times H2O. 2.2 to 3% by weight of clinker of gypsum is added to the cement clinker. Gypsum reacts with tricalcium aluminate and forms an insoluble calcium sulfoaluminate. And ultimately a tricalcium aluminate hydrate is formed. As more tricalcium aluminate comes into the solution, the composition changes, the sulfate content decreases and decreases continuously. The rate of reaction of aluminate is high, and if this readjustment in composition is not rapid enough, direct hydration of tricalcium aluminate may take place. The hydration of tricalcium aluminate is retarded by calcium hydroxide, which is liberated by the hydrolysis of tricalcium silicate. It happens due to the fact that calcium hydroxide reacts with tricalcium aluminate and water to form calcium aluminohydrate, which forms a protective layer of coating on the surface of unhydrated grain of tricalcium aluminate. Almost 40 parts, tricalcium aluminate reacts with 40 parts of water by weight, which is a much higher proportion of water than required by the silicates. The presence of tricalcium aluminate in cement is undesirable. It contributes to strength after 3 days and more especially after 24 hours strength of cement or concrete. When hardened, cement paste is attacked by sulfates and disruption of cement paste takes place due to the formation of sulfoaluminate from tricalcium aluminate. The high rate of heat developed also causes cracks in the concrete, which is not desirable. However, tricalcium aluminate acts as a flux, reducing the burning temperature of clinker, which results in saving of fuel during the cement making process. When we talk about the tetracalcium aluminoferrate, it also acts as a flux. If tetracalcium aluminoferrate is not present, the reaction in the kiln would progress much more slowly. During the production of cement, the reaction in the kiln it will progress much more slowly and would probably be incomplete. Gypsum with C4AF is that tetracalcium aluminoferrate forms calcium sulfoferrite as well as calcium sulfoaluminate, and in its presence accelerates the hydration of cement. Gypsum reacts both with tricalcium aluminate and tetracalcium aluminoferrate. Then we have calcium hydroxide. The calcium hydroxide is produced during the hydration of tricalcium silicate and dicalcium silicate. It constitutes 20 to 25% of the volume of solids in the hydrated paste and makes the concrete porous, weak and undurable. Calcium hydroxide also reacts with sulfates present in water or soil to form calcium sulfates, which further react with tricalcium aluminate and cause a deterioration of concrete. The effect of calcium hydroxide can be reduced by using pozzolanic materials. As I was talking about the admixtures are added, which are added in order to modify the properties of concrete, and likewise are the materials called as pozzolanic materials, which are added to modify the performance of cement or concrete. And these pozzolanic materials are added in order to decrease the amount of calcium hydroxide present. The only advantage of calcium hydroxide is that its being alkaline in nature maintains the pH value of water around 13 in the concrete, which reduces the corrosion of reinforcement. Once we use the concrete in case of reinforcement. Okay, thank you.